Hey everyone, welcome back to my channel Security Bit.
Welcome to episode 4 of AI Security Podcast.
On my channel Security Bit. Please note that this podcast uses audio which is AI generated, but all the content is vetted by a human, which is me.
Welcome to this deep dive. Today we're tackling large language models. And let's be clear, these are really the engines driving so much of the generative AI buzz.
Yeah, definitely. They're kind of the dynamite behind it all, you could say.
Exactly. They make things like, advanced chatbots even possible.
Precisely. At their core, large language models, LLMs, they're really advanced deep learning systems.
Deep learning, okay.
And they're trained on just absolutely massive amounts of text data. Huge amounts.
Which lets them understand language.
Understand and generate new text. That's the key. Text that can sound remarkably human. It's pretty incredible stuff.
It really does feel a bit like magic sometimes, doesn't it? You type something in, you get this coherent response.
Mm-hmm.
But underneath, it's this incredibly complex system. People often call it a black box, right?
That's the term, yeah. Because figuring out exactly how they arrive at an answer can be, well, tricky.
So that's what we want to do today, sort of pull back the curtain a bit.
Good plan.
We'll explore what these pre-trained LLMs actually are, where you might find them, out in the wild.
Right.
How you can actually start using them, and maybe touch on some of the big examples too.
Sounds great. And maybe a little history helps too, to see how we got here.
Oh, definitely. Where do we start?
Well, a really big moment was back in 2014, the introduction of the attention mechanism.
Attention mechanism. Okay.
It was in a key research paper. Basically, a new way for AI to focus on the most relevant parts of the input data. Kind of like how we pay attention.
Right. That paper,
All right.
was it neural machine translation by jointly learning to align and translate? Bit of mouthful.
That's the one. Technical, yeah, but the impact was huge. It helped AI move beyond just processing things in a straight line.
Got it.
Then, fast forward to 2017, another massive paper, Attention is All You Need.
Ah, the famous one.
Yeah.
That introduced the transformer model.
Exactly. The
Yeah.
transformer. Sounds like sci-fi, I know.
It really does.
But that architecture is essentially the backbone of most modern LLMs.
Okay, the backbone.
It uses two main parts, an encoder to kind of process the input text,
Right?
and a decoder to generate the output.
Encoder, decoder. Makes sense.
And crucially, it heavily relies on something called self-attention.
Self-attention. What does that do?
It lets the model weigh the importance of different words in a sentence, so it understands relationships, context, much more nuanced than before. It's not just reading words one by one.
It's seeing the connections between the words.
Precisely how they all relate.
And these transformer models, they kind of learn on their own. You mentioned unsupervised training.
Yeah, exactly. That's a big part of it. They're fed just enormous amounts of raw text. Think of it like them reading a huge chunk of the internet.
Just absorbing it all.
Mm-hmm. And through that process, they start to pick up grammar rules, patterns in different languages, tons of general knowledge.
All without someone explicitly teaching every single rule.
Correct. It's learned implicitly from the data itself.
Okay, that's a helpful bit of background. So let's dig into this pre-trained aspect. What does pre-trained really mean here?
Good question. Pre-training basically means they get this broad general education first. They're trained on those massive, diverse text data sets before you ask them to do anything specific.
Like a foundational knowledge base.
Exactly, before they specialize.
And the data. You said massive. Where does it all come from? It must be an unbelievable amount.
It is staggering. So models like, say, Llama, they use data from sources like Common Crawl.
Common Crawl, what's that?
It's basically a huge archive of web pages,
Oh.
billions of them.
Wow. Right.
Plus code repositories like GitHub, all of Wikipedia, digitized books from Project Gutenberg. We're talking trillions of words.
Trillions. So basically a huge slice of the digital world.
Pretty much, yeah. Especially everything that's become available since the web really took off in the 90s. It's an unprecedented resource for this kind of training.
So they're learning from our collective digital output, in a way. Now, when they process text, it's not just reading letters, is it? There's that conversion step, embedding.
Yes, exactly. Embedding. Each word, or sometimes smaller bits called tokens, gets turned into a numerical vector.
A list of numbers.
A long list of numbers, yeah, in a high-dimensional space. And each number, each dimension, sort of represents a potential aspect of that word's meaning.
Like edibility or something.
Could be. Imagine a dimension for fruitiness. Apple would have a high score there. Table would have a low score.
Okay, I see.
So words with similar meanings end up closer together in this abstract meaning space. Apple is closer to banana than to car. It captures semantic relationships.
That makes sense. Vectors capturing meaning. Now, you also mentioned keys, queries, and values earlier inside the transformer.
Right. That's where the context understanding gets really sophisticated. When a token goes into the transformer, it gets transformed into these 3 different representations.
The key, query, value.
Yep. Using special matrices learned during pre-training. These matrices help emphasize different facets of the token depending on the context. The query is sort of what the token is looking for. The key is what other tokens are offering, information-wise. And the value is the actual information content of that token.
So if I have the cat chased the mouse, the query for cat is looking for related words like chased.
Exactly. The query of each token gets compared to the key of every other token, including itself.
Right.
This comparison gives the score how relevant is each token to this one. For cat, the keys for chased and do would likely score high.
Indicating a close relationship in this sentence. And then what happens with these scores?
They get fed into a function called softmax,
Softback.
which basically turns these raw scores into probabilities, a probability distribution. It tells the model how much attention each word should pay to every other word.
So it's calculating importance on the fly for that specific context.
Precisely. It's a dynamic map of relevance.
Okay.
Then these attention probabilities are used to weight the values of each token.
So important words contribute more.
Exactly. You multiply the probability by the value. Then you sum up all these weighted value vectors.
And that gives you...
A new vector for each token. But this one is contextually enriched. It now contains information about its relationship with all the other relevant words in the input.
And that's the vector the model uses to predict the next word when it's generating text.
Yes, absolutely. That enriched output vector goes through more neural network layers,
Right.
which do more calculations, ultimately leading to predicting the most likely next token in the sequence.
And that prediction process, that's how it learns during pre-training, trying to guess the next word.
You got it. It's called self-supervised learning. It compares its guess to the actual next word in the training data.
Sees if it was right or wrong.
Exactly. If it's wrong, it adjusts its internal settings, those weight matrices we talked about, using a process called backpropagation.
And it does this billions, trillions of times.
Billions and billions of times across all that data. It constantly refines its ability to predict what comes next. And in doing so, it learns language structure, facts, reasoning patterns.
It's fascinating. Though some people argue it's not really understanding, right? More like incredibly sophisticated pattern matching.
That's a huge ongoing debate. Some see these emergent abilities as a form of understanding. Others argue it's more like artificial perception, just predicting the next token really well rather than true artificial intelligence with goals and intentions.
It's a philosophical point almost.
Yeah,
Are they thinking or just predicting?
exactly. It's a tricky question. But regardless, their ability to process and generate language is undeniably powerful.
Okay, so we have these powerful pre-trained models. Where do we actually find them? Are they locked away in research labs?
Not entirely, thankfully. The landscape has really opened up. You've got some models that are truly open source.
Meaning the code, the weights, everything is public.
Yep. Anyone can download, use, modify them. Models like Llama 3.2 from Meta or Tulu 3 from the Allen Institute for AI fall into this category.
That's great for researchers, developers.
Absolutely. Then you have proprietary models. These are owned and controlled by specific companies. Think GPT-3 or GPT-4 from OpenAI or Claude from Anthropic.
So you might need to pay or use them through an API.
Often, yes. Though sometimes there are free research previews or tiered access.
So if someone wants to start exploring, where should they look?
A fantastic place to start is Hugging Face.
Hugging Face.
Yeah, it's a platform, kind of like a hub for AI models. They host thousands of pre-trained models, including many of the open source ones we mentioned. It makes them really easy to access and use.
Okay, Hugging Face, good tip.
You can also often find models directly from the creators. Meta has llama.com for their llama models.
Right.
Allen Institute for AI has info on Tulu 3. Vicuna, which is built on Llama, but fine-tuned on conversations.
Oh yeah, you mentioned that one.
That's open source too, from LMSYS. Even models like the original Bloom or Llama, while maybe having some usage restrictions, were source available.
Lots of options.
Definitely. And newer players, too, like Mistral AI. They've released models like Mistral 7B and Mistral 8x7B under the Apache license. Very open.
Apache licensing.
And DeepSeek just put out DeepSeek R1, a huge open weight model.
Open weight means the trained model is available, but maybe not the training code.
Generally, yeah. The weights themselves are shared.
So there's a spectrum. Fully open, source available, open weight, proprietary.
Yeah.
How about using them to build stuff, like apps?
Right. For many models, especially the big proprietary ones, the main way to integrate them is through APIs, application programming interfaces.
APIs, like a doorway for developers.
Exactly. A set of tools and rules so developers can plug the LLM's power into their own software. OpenAI, Anthropic, AI21 Labs with Jurassic 1, Cohere with Command, they all offer APIs.
Lighten, too, you mentioned, with Paradigm.
Yep, Lighten offers Paradigm via API, claiming some serious performance.
So a developer could, say, build a customer service bot for a website using one of these APIs.
Absolutely. That's a classic use case. And Hugging Face isn't just a place to find models. They also provide tools and libraries that make working with these models, whether open source or via API, much easier for developers.
Okay, makes sense. So we know where to find them. How do you actually use them? Do you need to be like a coding genius?
Not necessarily, especially for basic interaction. The simplest way is through prompting.
Prompting, just talking to it.
Pretty much. Giving it text-based instructions, questions, examples. You guide its response through your input.
So the quality of my question affects the quality of the answer.
Massively. How you phrase your prompt makes a huge difference. It's all about clarity and structure.
People talk about prompt engineering, right?
Exactly. It's become a real skill learning how to craft prompts that get the best results from the LLM. Sometimes really clever prompting can achieve things you used to need fine-tuning for.
Ah, fine-tuning. You mentioned that. How's that different?
Fine-tuning is more involved. You take a pre-trained model, one that already has that broad knowledge,
Right.
and you train it further on a smaller, specific data set tailored to your task.
So specializing it.
Exactly, like taking a general LLM and fine-tuning it on medical text to make it better at answering medical questions, or on legal documents.
So prompting is for quick results in a conversation. Fine-tuning is for deeper specialization.
That's a good way to put it.
Yeah.
And there's another technique, RLHF.
RLHF.
Reinforcement learning from human feedback. Basically, humans rate the model's outputs thumbs up, thumbs down, and that feedback is used to tweak the model to better align with what humans find helpful, harmless, and honest.
Oh, making them safer and more useful.
That's the goal, yeah. It's a crucial step for many widely used models like ChatGPT or Claude.
Now, when you're prompting, having that conversation, is there a limit to how much it remembers from the chat?
Yes, absolutely. That limit is defined by the context window.
Context window, like its short-term memory.
Kind of, yeah. It's the amount of text, both your input and its previous responses, that the model can actually consider when generating the next response.
And these vary in size.
Hugely. Some models have smaller windows, maybe a few thousand tokens. Others, like Claude 2, have massive ones, up to 100,000 tokens.
100,000 tokens, that's like a book.
Roughly, yeah. A short novel's worth of context. A bigger window means it can handle longer conversations or analyze much larger documents without losing track of what's going on.
That capability must unlock a lot of applications. So what are people actually doing with these LLMs right now? What are the big uses?
Oh, the range is already huge and growing fast. Generating creative text is a big one.
Like writing marketing copy, emails?
Exactly. Articles, blog posts, scripts, poems. Models like GPT-3, ChatGPT, Claude, Llama 2, Cohere Command are all used for this.
Helping with writer's block, maybe?
Definitely. Or just speeding up the process. Another cool area is improving writing style. AI21 Labs has a tool called WordSpice, specifically for suggesting stylistic improvements.
Oh, interesting, like a super thesaurus.
Kind of, but more nuanced. Understanding tone and voice.
What about research?
Huge potential there. Summarizing dense articles, analyzing data for patterns, finding relevant papers in vast literature databases.
I could save researchers so much time.
Potentially, yes. There's even exploration in fields like medical education.
Though I imagine you need to be careful there. With accuracy.
Absolutely critical. Hallucinations where the model just makes stuff up are a real issue.
Right, hallucinations. And bias from the training data.
Also a major concern. And that black box problem, not always knowing why it gave an answer, these are important limitations to keep in mind.
Definitely. Okay, so we've talked concepts, Finding them, using them. Let's make it more concrete. Can we run through some specific examples? We've named a few.
Sure. Let's start with Llama from Meta AI.
The open source one?
Mostly, yeah.
Yeah.
Based on the transformer trained on public web data, that open license was a big deal. Llama 3.2 came in different sizes, like 11 billion, 90 billion parameters.
Parameters being like the knobs and dials inside the model.
Roughly, yeah. A measure of its size and complexity. And because Llama was open, it spawned descendants like Vicuna, Orca.
Built on top of it.
Exactly. Then there's Tulu 3 from the Allen Institute for AI.
Also open source, you said. And
Yeah.
big.
Very big. 405 billion parameters. What's cool there is their fine-tuning. They use reinforcement learning, especially reinforcement learning from verifiable rewards.
Meaning?
For tasks where you can check the answer, like math problems or following instructions precisely, they can fine-tune it based on whether the outcome is actually correct. Helps boost accuracy on those tasks.
Clever. And Vicuna.
Right. Vicuna from LMSYS, derived from Llama, but then fine-tuned specifically on conversations from a site called sharegpt.com.
So it's trained on real human AI chats.
Yep. It's about 33 billion parameter, so smaller than the giants, but performs surprisingly well, especially in conversational tasks. Shows the power of good fine-tuning data.
Okay. And we have to mention OpenAI, GPT-3.
The breakthrough model, really. 175 billion parameters, showed amazing ability to spot patterns, generate natural text on almost anything.
And ChatGPT.
Its conversational cousin. Same family, but specifically tuned for dialogue. Made LLMs accessible to millions. We don't know its exact size, though.
Right. OpenAI keeps some details close. How about Claude from Anthropic?
Also, size unspecified, but
Yeah.
known for safety focus, and that huge context window we mentioned, 100K tokens for Claude 2.
Useful for long documents. Any others?
Definitely. AI21 Labs has Jurassic 1. About 178 billion parameters, big vocabulary, also conversational.
Okay.
Cohere's command model, similar power, but notable for working well in over 100 languages.
Wow. Multilingual.
Lighten's paradigm, claiming performance beyond GPT-3 in some areas. And that DeepSeek R1, 671 billion parameters, open weight, aiming for top-tier performance at lower cost.
It's a crowded field. Lots of competition.
Fierce competition, and it's constantly evolving. A huge trend now is multimodality.
Multimodality, meaning more than just text.
Exactly. Large multimodal models, LLMs, they can process images, audio, sometimes video, alongside text.
Like GPT-4 can understand images.
Yep. GPT-4 with vision. Google DeepMind has Gemini. Mistral released Pixtral 12b, which handles images too. It opens up a whole new world of possibilities when models can see and hear as well as read.
Mind-boggling, really. So these pre-trained LLMs, they're clearly incredibly powerful tools.
No question. A shortcut to generating and understanding text in ways we couldn't before.
But important to remember the limitations, too. Bias, hallucinations.
The black box nature, the ongoing debate about true understanding. Essential context.
Absolutely. And for anyone wanting to see them in action, you mentioned Hugging Face, llama.com, the company sites.
Great places to start exploring, yeah. Many have demos you can try right in your browser.
Well, this has been fascinating. As these LLMs get woven deeper into our lives, it really makes you wonder, how will our definitions of knowledge, maybe even intelligence, start to change?
That's the good question, isn't it? And what's our responsibility in guiding how these incredibly powerful tools are developed and used ethically? Lots to think about.
Definitely food for thought. Thanks for taking this deep dive with us today.